Good morning, friends. Today I am here to talk about the topic One Way Anova. So, myself, Ashwin Babu. This is an extension of two independent sample titers. The response variable is the variable you are up comparing. The factor variable is the categorical variable being used to define the group. We will assume k samples example as group. The one way is because each value is classified in exactly one way. That's why we called it as one way ANOVA. Example including comparison by gender, race, political party, color, etc. The condition or assumption that we are used in this one way ANOVA. The data randomly sampled. The variance of each samples are assumed equal. The residual are normally distributed. Step 1 is to check the hypothesis. The first hypothesis, null hypothesis. The null hypothesis is that the means are equal. H naught means mu1 equal to mu2 equal to mu3 up to mu k for k elements. And the alternative hypothesis that the at least one of the mean is different. Think about the same straight game where there are those things are kind of the same, but one of those things is not like the others. They don't have all to be different, just one of them. Step is declare your null and alternative hypothesis first. The alternative hypothesis assert that at least one group mean different considerably from the others, contrarily to the null hypothesis H naught, which prepose that there is no difference between the groups means. So it is the two hypotheses that we are setting. Statistics classroom is divided into three row: front, middle and back. The instructor noticed that the further the student were from him, the more likely they were to miss class or use an instant messenger during the class. He want to see if the students further away did wrong to the exams. H naught means mu of equal to mu m equal to mu b. So this is the first step, setting the hypothesis. So the next step is to collect data collection. Collect data from each group you want to compare. The data should be numerically and preferably normally distributed. That is, we want to check it. A random sample of the students in each row was taken. Here we are taking the random sample of the students. The score of those students of the second exam was recorded, and the exam scores have been recorded in the form of front, middle and back. That data are given here, and the summer statistics of the grades of each row and shown in the table below. Here we can see the summer statistics of the grades of each row and shown in the table below by sample size, mean, standard deviation, variation of front, middle and back. Variation is the sum of the squares of the deviation between a value and the mean of the value. Sum of squares is observed by SS and often followed by a variable in uh, permanence such as SS or SS. Also, we know each sum of squares we are talking about. And next is to all are the values are identical. We have to check that. So no, there is some variation in the data. This is called total variation, denoted as SS total for the sum of squares, that is called variation. Sum of squares in another name for variation. Are all of the sample means identical? No. So there is some variation between groups. This is called the between group variation, sometimes called the variation due to the factors denoted by ssb. For sum of squares means variation between two groups, each group of the values within each group identical. No, there is some variation within the groups. This is called the within group variation, sometimes called the error variation, denoted by SS for sum of squares within the group. There are actually two sources of variation: the variation between groups or the variation due to the factor. The variation within the groups or the variation that can't be explained by the factor, so it's called the error variation. So we can see the basic ANOVA table by source, source between within total and SS, DF, MS, F and P. This is the basic one-way ANOVA table. And the next one is grand mean. The grand mean is the average of all the values when the factor is ignored. It is a weighted average of the individual sample mean. Grand mean, for example, is 65.08. And next one is between group variation, SSB. The between group variation is the variation between each sample which and the grand mean. Each individual variation is weighted by the sample size. The between group variation, for example, is SSB equal to 1902. We can say that, for example, that ANOVA does not around to be 1902, but if you don't around the intermediate steps, then it does. Here our goal is to show the ANOVA table in mini table and in return of 1902. And what is within group variation? The within group variation is a weighted total of the individual variation. The weighted is done with the degree of freedom. The degree of freedom, each sample is one less than the sample size for that sample. Degree of freedom. A degree of freedom occurs for each value that can vary before the rest of the value and predetermined. For example, if you had six numbers that had an average of 40, you would know that the total had to be 240. Five of the six numbers could be anything, but one first five are known. At least one is fixed, so the sum is 240. The degree of freedom would be 6 minus 1 equal to, which means 5. The degree of freedom is often 1 less than the number of value. The between group degree of freedom is 1 less than the number of groups. We have 3 groups, so degree of freedom b equal to 2. An example, within the group, degree of freedom is the sum of the individual degree of freedoms of each group. And we can say an example size are 7, 8, 9. Then the degree of freedom means 7 minus 1 6, 9 minus 1 8, 8 minus 1 7. So 7 6 plus 8 plus 7. The total degree of freedom is 1 less than the sample size, that is equal to 24 minus 1 equal to 23. So the next step is to filling the degree of freedom giving this table. Here we can see that the degree of freedom. And the next step is the variance. The variance is also called as the mean of squares, often with a accompanying variable MSB or MSW. And there are an average square deviation from the mean and are founded by dividing the variation by degree of freedom. MS equal to SS by degree of freedom. We can see the MSB, MST, MST by dividing by degree of freedom. So we'll get the answers, notifying that the ms total is not the sum of ms between and ms within the work for the sum of squares ss total, but that the mean square ms total. The ms is usually shown. Next step is to completing the ms given data that is showing in the picture. And the next one is to find the special variance. The ms within is also known as the pooled estimate of the variance, since it is weighted average of the individual variance, sometimes observative. The ms is an variance of the response variable, not technically a part of ANOVA table, but usually none of this less. And next one is to f test statistics. And f test statistics is the ratio of two sample variance with ms and msw are two sample variants that what we divide to find f is equal to ms by ms. For our data, f is equal to 951 divided by 161.2, that is equal to 5.9. And the next step is to adding the f table that we can see in this table. F test is a right tail test. The F test statistics has an F distribution with F degree of freedom numerator, degree of freedom, and DF denominator. The value in the area of the right of the test statistics is equal to P of f of 2 comma 21 greater than 5.9, that is equal to 0.009. And next, completing the table with the p values. So the p value equal to 0.009, which is less than the significant level of 0.05. So we reject the null hypothesis and has accept the alternative hypothesis. The null hypothesis is the same, is that the mean of the three rows in class were the same, but we reject that. So at least one row has different mean. There is enough evidence to support claim that there is a difference in the mean source of front, middle and back classes. The ANOVA doesn't tell the row is different, which row is different. You would need to take a look at the confidence intervals or run post HOC test to determine that. Anyway, thank you.